Hi everyone, my name is Steve Goodwin and this is my anchor test video number 113. Today I'm going to be testing this 44-pound roll bar Rocna Anchor. Now previously I tested another one of these same sized Rocnas, but it was manufactured many years ago and had some significant flaws. This anchor is brand new. It has a quality control sticker from October 2020. And I compared it on the bench to that older anchor, and I outlined 8 different ways that this anchor is better. I'm not going to go through all those with you right now. If you want to see those, it's my previous anchor video. Correction, it's not an anchor video. It's my previous video where I just talk about this new test boat and that anchor on the bench. So you can go back and watch those. Today I'm just going to do the boilerplate testing that I've always been doing. Those that have been following know that I just got this new boat and I am equipping it to be able to do very high holding power tests with a winch. And I don't have that set up fully operational yet. So today I'm just going to do the normal testing that's been going on with all these anchors for the last half a year or so. So this anchor has never been in the water. Got perfect conditions right now. There's no current. We're at slack low water. I'm here at the loose sand site, so I'm going to give it a veer test. First test is 840 pounds of force and let the boat swing all the way around 180 degrees, and then a max power check. So let's get with it. Enjoy. As mentioned, this is the clean, loose sand seabed. The water's quite turbid. It is summertime, and that is when lots of organic material is suspended in the water column. So we won't get those beautiful clear pictures that we did in wintertime. We've now ramped up power at 860 pounds of thrust, and the veer has commenced. And you'll see that the anchor is moving, and that motion never stops. In fact, it increases a bit at times, but it's really quite steady. Here I've jumped ahead. The anchor just does this the whole time, and I'm not going to show you all of it. At the 90-degree mark, the anchor releases. It did coincide with coming in contact with this seaweed patch, so I'm going to go ahead and give the anchor another try. But that was a full release at the 90-degree mark of the veer. I can see just a little bit of seabed still attached to the fluke, so no real clue there. Alright, with things cleaned off, do another try for this clean, loose sand veer. The initial set was perfect, and the performance did not change. It had the exact same behavior, a continuous motion through the veer. There was a release at the 70-degree mark this time, but I went ahead and kept pulling it up a bit. And sure enough, the anchor reset, and reset firm. So firm that I was able to continue the veer, and the anchor maintained engagement with the seabed to complete that full 180 degrees. So that was good. Then after that 180 degrees of veer, I straightened the boat out and ramped up power. And again, motion never stops. It just keeps right on trucking along there. We see the anchor has risen up, and let's call that a packed roll bar. The roll bar is clearly above the level of the seabed, but we don't see it because it is just so covered. Now here I've ramped up power to over 1,200 pounds of thrust, which is a really high number, but I don't know how much good this is to you if you're trying to anchor your boat, because boat speed was very high. It was up, well, it reached 2 knots at that 1,200 pound mark, and that's when I discontinued the test. You can be the judge of how useful an anchor is that's moving at, say, 1 knot. Gives you some time, but you're certainly not going to be sleeping. I have now conducted the same test on 4 40-pound range anchors, and the 51-pound Viking and the 44-pound Mantis M2 were both nearly perfect in this test. Very, very little motion during the veer, and the 1,150 pounds of pull they received at the end of the veer. The other big anchor that I've tested here was the 42-pound Epsilon, and it was marginal like this Rocna. It had a little more solid hold during the veer, but it had multiple releases. Next test site will be over at the soft mud location. I'll show you some clips of the boat ride over there so you can see how the new boat is laid out. As you can see, I chose a vessel that does not have any kind of accommodations, no chairs, no console, no windshields. I wanted a wide open workboat, and this certainly fits that bill. As you can see, I'm sitting in just a collapsible or folding chair. That was just temporary. I kind of had thought I would build a custom little seat back there that would be just right for my needs. But frankly, that chair is working out great. I might just leave it at that. We'll see. Okay, next test is the soft mud at Scow Bay. We're running 5-to-1 scope with the long chain rode. Going to shoot for a 500-pound, 180-degree veer. Saw that on the initial set, the anchor just immediately disappeared and dove out of sight. I've cut out much of the footage. Here we're watching midway through a very successful 500-pound veer. You can see that there is very, very little motion of the anchor with respect to the seafloor. A little bit of current is moving turbidity by, but again, that's not the anchor moving, that's just the water moving by. Here's some clips, or a clip, of the top side during that veer. You can see the boat is moving to starboard, and I'll mention that this boat does not like to move sideways as well as my other test boat I had been using. I was able to get about 2 knots with the previous boat, but this boat, it doesn't really want to go much more than about 1.5 knots. This clip, the veering portion is completed, so the boat's just pulling straight ahead with increasing thrust, and it did really quite well. Up to about 900 pounds, motion was very slow, very minimal. At 1,000 pounds, motion was steady at just under 1 knot, and then at 1,100 pounds, it basically released or was going over 2 knots, so I just continued the test. But if we compare this to the 4 other anchors that I have already tested with this protocol, this was very favorable performance. Only the 51-pound Viking was better. Its drag was only about 0.5 knot at 1,100 pounds. The 40-pound Nox was similar. It had what I wrote down as small motion at 900 pounds, and then at 1,000 pounds it had sort of a faster motion. Its veer was really good. But the 45-pound M2 and the 44-pound Epsilon, they were far, far less performance than this 44-pound Rocna here in this soft mud veer. It's going to be great when I get that winch online. Pulling that last bit of vertical chain and anchor up will be a lot easier. Next test is just a holding power check in the Cobblestone. It's real shallow here, only 5 feet, and use about 100 feet of road. So the idea is that the road never lifts off from the seafloor, in effect having infinite scope. I have tested all the larger anchors here. It's over a dozen, so we get a good comparison. And this was kind of a unique result in that I could not repeat the best holding, and that best hold that this anchor did was 395 pounds, and again, I couldn't get it to repeat. Every other anchor I've done was very, very repeatable. It did achieve 315 pounds again, so that's the rating I think I'll give it. And it sounds low, but frankly, this is a really terrible seabed. I really wouldn't recommend anchoring here unless you absolutely had to. But if you did, the formula, so it seems, for getting good holding here is having a very tall shank, because the horizontal portion of the shank just cannot be forced down between those big rocks. Normally I get great pictures here, but between the turbidity and my failure to shorten up the camera tether, we just got some bad imagery. All that jiggling is the fact that the camera float is at the surface, so little waves are just causing a constant jiggle. In any event, there's not much to see. Obviously the shank never buries, and the fluke does get covered with rocks at times, so it's always upright, making a good effort, but that's just all you're going to get, 300 or 400 pounds of holding. I'll share what little I know about our geology and the composition and origin of our seabeds around these parts here in Puget Sound. So up ahead there, you'll see an embankment or a cliff, and that is really, really common. The story I hear is that is glacial material that's left over from the last ice age. The ice was about 4,000 feet thick here, and it receded 16,000 years ago. The waters rose up, and the waves have been nibbling away at the edges of these land masses ever since. You'll see piled there on the beach and at the base of the cliff, there's loose sand. That could have fallen away just this last winter. These cliffs recede maybe inches or perhaps a foot per year. In any event, the material gets washed seaward by waves and currents, and whether you get gravels, sands, or muds, I believe depends entirely on how much and which direction the currents flow. For example, here in Scow Bay, there is very, very little current, and as a result, the fine materials are not allowed to be washed away. So it's a very shallow area, very little erosion along the shorelines. And I believe where I test, I think that's mostly organic material that just slowly settles to the bottom and builds up over the years. And again, there's just not enough current to wash it away. If there's any geologists watching this on YouTube, please leave a comment, add to it, or even better, correct me if I am mistaken about any of this. We've now moved over to the sandy mud seabed. This is the place where I did all my early anchor testing starting 5 or 6 years ago. This is a rope-only veering test. The target was a 850-pound pull and then let the boat drift all the way around 180 degrees. Unfortunately, this anchor did not hold the target thrust. It actually got there momentarily, but at 860 pounds, the anchor immediately released. I say immediately because prior to this release, it seemed pretty solid, but it's as if the seabed just couldn't handle it. It broke and off it went with a big ball of mud. The anchor did reset fairly firmly, but it held less this time. It was around 600 pounds on that release. So I went ahead and retrieved the anchor and got it cleaned off. Fair amount of mud there visible, and I gave it another try. So for this second attempt, I did not try for the 860 pounds of thrust. I downgraded and shot for 535 pounds of thrust. Kind of give it a break, see if it'll actually conduct a veer. And it did hold that. It was pretty solid at 535, but at the 10 degree of veer mark, just as I was getting going, the anchor released fully. So I've now conducted this test on about 15 40-pound range anchors, and this is among the worst, or perhaps the worst performer of them all. Now, I know some of you folks don't like to see the rope-only anchor testing, so here we are in the same seabed. Scope's only 5-to-1, but we've added 80 feet of chain, and I'm just doing a straight line pull. The anchor was holding 860 pounds quite nicely, but at 945 pounds, the anchor released abruptly and would not reset. I let it drag for a considerable distance, slowed the boat down to 0, started up again, no resetting. Anchor's hopelessly mud-fouled. I'll mention that I've tested at least 3 17-pound anchors that were able to hold this no problem. So the anchors that were less than half the weight were performing better. Here's some topside footage of the final moments from that straight line pull. This is pulling about 900 pounds here, maybe a little more, and then we'll see a release here. It's not too big of a jerk in the boat. No chance I'm going to be falling over when these anchors let go at those kind of power numbers. I'll mention that the new motor and prop combination that I have, it really pulls hard. We did a calibration test tied to the dock, and it made over 1,300 pounds of thrust. The propeller that we're using to get that is the one that's mounted in this picture. Note that the hub is much larger diameter than the lower right-hand prop's hub, and I think that causes an illusion. It makes the prop maybe look a little smaller, but in fact it's actually larger diameter, has much more blade area, and is finer pitched. So it's truly a real workhorse propeller. The downside is it's pretty slow. I'm only cruising around at about 16 knots. It'll go faster than that, but it takes a lot of RPM. Here's another view of that prop. Notice how the hub of the propeller is much larger than the diameter of the lower leg portion ahead of it. The idea, I believe, is that water is able to flow through the hub and mix with the exhaust gases. I'm not quite sure how that is a benefit or if it is a benefit, but I will say that this prop pulls harder than any other of the 4 propellers that I have done high bollard pull testing. Okay, the final testing will be the 180-degree reset test. First group of 10 that I did was with the long chain. That's 80 feet of chain, balanced nylon. Both of these groups of 10 were at 5-to-1 scope. But there was a big difference. All 10 of the resets with the long chain were quite good, and pretty much all 10 of the short chain resets were poor. I'm not going to show you all these for 2 reasons. One is it's kind of boring, kind of the same thing happens. And the other thing is with all this turbidity, we just don't get to see much. So take my word for it. I just use the same procedure I always do. Try to shoot for 3.5 knots up overhead, directly over the anchor. And when things come up tight, I add the power, give it a good burst, over 500 pounds of thrust. And like I say, with the long chain, it was pretty much 10 for 10. The GPS track going back and forth didn't change much. It just stayed right within the same boundary, and indeed, we don't see much movement on the bottom video. Here's some topside video of what goes on during these direction changes. I pull from just one leg of the bridle, so it's an asymmetrical pull, which means I can't keep that burst on for very long, or else the boat will change direction drastically. It's nice having the control tiller on the engine for these tests, because it puts myself right at the transom, and I can look over the rear and make darn sure that that road is clear of the propeller. With the old boat with the wheel steering forward, I was pretty blind, and thankfully I never did chop up a road, but this is a bit more confidence inspiring, being able to have a look back there as I'm reversing and turning to get the boat reoriented for each reset. And the last group we'll take a peek at is the short chain resets, and it's really not so good. And before you say, hey, this is too short a scope and too short a chain for any anchor to work, well, consider that I've tested 2 17-pound anchors. That was the Excel number 1 and a 17-pound Mantis M2. Both of those could handle this short chain resetting no problem, and they did it at 3.5-to-1 scope. So there's no excuse here. I mean, if you want to say, well, you've got to use a whole bunch of scope to use a Rocna, okay, that's fine, but boy, why limit yourself? There's other anchors that can perform really quite well at shorter scope, and I'll add, I've added longer scope. We just saw some 7-to-1 here, and the Rocna just doesn't like this seabed. It is truly not about the scope and not about whether you use enough chain. This anchor mud fouls in this sandy mud seabed. There's just no question about it. This is the 3rd Rocna anchor that I have tested, and they've all done the same thing. I will say this anchor is perhaps a little better than that previous 44-pound roll bar Rocna with those flaws, but it is certainly not a night and day or a leap better. This anchor is still quite poor in my testing, and speaking of which, let's get right to the performance chart and see how the numbers add up. So the big question on my mind is, did this new 2020 version of the 44-pound Rocna, is it improved over that visibly flawed early version? And the answer is yes. It is better, but not light years better. It's, it moved up a few notches there. It's now better than a Bruce on my charts. I think it has the potential of climbing higher, maybe getting up above the Delta, CQR, maybe the Knox. We see there in those unpopulated in-water performance columns, the soft mud veer and the clean sand columns. I don't have numbers there yet, but we see that this new Rocna did very well in the soft mud veer and average there in the clean sand. So again, it has the potential of climbing, but as it is, it's still quite low on my charts. As I've stated many times, it would appear that the seabeds in my area favor some anchors and of course are a detriment to others. And maybe it's just unlucky for the Rocna to fall in my lap, and I'm the anchor tester here in the Pacific Northwest, and maybe that's just the way the ball bounces. Perhaps if I was a tester in some other location, maybe the Mediterranean or somewhere tropical, perhaps this whole entire list would be flip-flopped. I do intend to travel at some point and try to get more columns and try to represent every possible type of seabed. But for now, this Rocna remains quite low on my charts. I'll mention that in addition to being a little better in the in-water performance columns, better than the old version of the Rocna, look over in the engineering and strength column. Down at the very bottom, the original Rocna, I gave it a 4, not because I think it was not strong. These Rocnas are well built. I downgraded the original because it was just built poorly. The shank was welded on crooked, for lack of a better term. The late model Rocna was built very correctly. It was quite symmetrical, so it gets a 5 there. So between that and the performance increase, the total average went from a 2.6 to a 2.9. So in that previous video to this one, I did identify 8 differences between the old anchor and the new. I kind of have a feeling that one of them is really the primary driver of the boost in performance of the new anchor. And that is, it's this weld bead here that connects the two parts of the fluke together. They both have the same weld. The difference with the old one is that this one was not ground flat. There's a significant bump here, and mud that would otherwise travel freely along here, well, I think it just gets hung up. If I got some time, what I'd probably do is take a bead of caulking and put it across here and simulate this bump weld, and yeah, take it back out, do a bunch of reset testing, maybe scrape it off, do back-to-back tests and see if there's a difference. You might notice that there's these holes here. This is a modification I made, and I'll mention that the ratings that I gave previously for the Rocna Anchor were all based on the tests that I did before I modified the anchor. A very generous and talented individual saw a need for a soft shackle for my new test rig, and he went ahead and made these up for me and sent them. Very generous of him. These are super strong soft shackles. They're good for maybe 50,000 pounds. And they're just comically large, but the beautiful thing about them is even with a gloved hand, I can quickly make them up and undo and redo them. And I'd use this to connect the rods to the bridle of the test boat. And previously I would just tie a bowline knot, and that was adequate, but again, I'm taking gloves on and off, and it took a lot of time. So this is also good for the rope as well. It's kind of a large diameter for it to pass around, so there's a little less stress on the rope. And clearly this will just last forever. I don't know, I kind of call it the Godzilla of soft shackles. If you're not familiar with Dyneema, this is a kind of a modern synthetic rope material that is incredibly strong. It's equal or maybe a little more strength than steel wire for the same diameter, but it weighs, you know, a tiny fraction, a 1/7 or maybe it's a 1/10 as much. It actually floats. That's another good thing about this over a metal shackle in my use, because this is all just aft of the propeller. So I want all those connections and lines to be as buoyant as possible. So again, big thanks to that individual. I'll certainly have these for my lifetime. I'll give another thanks to all the people who are donating. If you want to do the same, there's links down below this video for my Patreon and PayPal accounts. So it's easy, just click on it and you can donate as little or as much as you want. I did spend a little bit more of your guys' donated money. Another Craigslist anchor. This is a genuine Bruce, 20 kilogram or 66 pounds. Now there is a theory that says that these genuine Bruce anchors are really good in the large sizes. The ones over 100 pounds, people just rave about them. But down in the smaller sizes, they have problems. And as we see on my performance chart, the 44-pound Bruce is just right down there near the bottom. They say, though, that at 66 pounds, that's when they start to perform better. So it's my intent to do careful holding power checks for all 4 of the Bruce anchors that I possess. I've got a 5 kilogram, the 15, 20, and now a 30 kilogram. So look for that coming up soon, and until then, anchor safely. So long.